Welcome back. Today's topic is regarding radical expressions and expressions with rational exponents. Now, these go hand in hand because you can go back and forth from writing an expression with a radical symbol or with a rational exponent. Remember, rational is fractional, so fraction exponent. Now, first we need to talk about a little bit of vocab. So let's look at the cube root of 125. Each of the pieces of this radical expression tells us something, well, really about what we're trying to do or how we simplify. So right here, this number right here, this is the index. Now, if there is no number in the index, it is an implied 2, like the square root of 16. There's an implied 2 in the index. We can write it in, but we do not have to. Now, we also have the radical symbol. So the square root, well, in this case it's a cube root. So that root sign, that is the radical. And the number underneath is the radicand. So our index tells us how many times we're going to multiply a number by itself to try and get the radicand. So I could also rewrite this with a rational exponent. So the radicand is our base. So this can also be written 125 to the. Now I can write it with a rational exponent. The index is always our denominator. And the 125 doesn't have a power, so it's got an implied 1. So it would be 125 to the 1/3. So a cube root of 125 is the same thing as 125 to the 1/3. So whenever you see a number that has a rational exponent, that means it's got a root, okay? A cube root, a fourth root, a square root, anything like that. So when we're simplifying radicals, what we're going to do is factor. And remember factors, greatest common factors, least common factor. Okay, so that's what we're going to do. Now, a way to make this easier is to go ahead and list all of the perfect squares and perfect cubes. Because if you're comfortable with those, you'll be able to have a shortcut. So I'm going to go ahead with my perfect squares. So 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, what was that, 7? So 8 is 64, 81, 100. Now if we go to 11, we have 121, 12, 144, 13, 169, 14, 196, and 15 is 225. What is up with my pen? So those are all of my perfect squares. So if you can recognize them, sometimes it'll make your life a little bit easier. So now let's go over our perfect cubes. So 1 cubed is 1, 2 times 2 is 4 times 2 is 8, 3 times 3 times 3, 27. What's next? 4 is 64, 5 is 125. The first 5 perfect cubes are really all that you need to recognize. You can absolutely learn more, but I don't expect you to recognize them off the top of your head. If you want to, 6 cubed is 216. 7 cubed is 343. Okay, I'm going to stop from there because, again, if you're not going to remember it off the top of your head, you don't need to. The first 5 are the most common that we see. I've definitely seen 216 and 343 into problems, but you can break them down if you don't remember them. So let's go ahead and start. Simplify the following. So our first expression, -3 root 121. Now, again, I don't have an index, so there is implied this is a square root, so there's an implied 2 there. Now, you could solve this super fast if you know what the square root of 121 is. So, square root of 121 is 11. If you didn't remember that, then you could go ahead and factor. So, what goes into 121? 11. So, 11 times 11. So, the square root of 121. So, we already have the -3, so don't forget to bring it down. Times square root of 121, 11. So, -3 times 11, -33. Beautiful. That's it. So let's try another one. Cube root of -27. So again, if you know that the cube root of 27 is 3, boom, it's 3. Well, it's not exactly 3 because we also have this negative that we have to make sure we don't forget about. But if you didn't remember that, you could go ahead and factor. So I know 27, I've got 3 times 9, and I can break 9 into 3 times 3. Because my index is 3, I'm looking for groups of 3. Well, I've got groups of 3, except it is -27, so it would be -3 times -3 times -3. So the cube root of -27, -3. Sweet. So let's look at another one. Now this looks weird, but it's really not bad. So the square root of 25/49. If you look at that and that's just like, oh goodness, that looks awful, you can go ahead and rewrite it. Square root of 25 divided by square root of 49. Now again, what's the square root of 25? What times what equals 25? 5. What times what equals 49? 7. If you didn't remember, you would simply break down 25 into 5 and 5, so you got a pair of 5s, so it's 5. Same thing with 49. 7 and 7, you'd have a pair of 7s. So, 5 7s. Cool. Fifth root of 32. Now that is a big root. So I'm looking for a factor that comes out of that 5 times. So 32, let's see. I look at 32 and I think, okay, I'm going to factor. So what multiplies to give me 32? 4 and 8. That's the first thing that comes to mind. Now I have to completely factor this because I need 5 of the same thing. So I'm going to break this 4 down, 2 and 2. Okay, now I can't break down 2. The only factors of 2 are 2 and 1, so I know I'm done. Now we go back over to 8. 8, 2, and 4. And again, our 4, 2, and 2. Now look, we have 5 2's. So the fifth root of 32 is 2. Okay, so those were all some pretty basic ones that simplified nicely. They had a nice rational answer. Okay, remember, anything that can be rational is fractional. Anything that can be written as a fraction. Now, let's look at some other ones. It says rewrite and simplify the following. So 8 to the 2/3 power. So again, if you have a 2/3 power, that tells me that I'm going to rewrite that as a radical so that I can simplify it. Go ahead and move down here. So 8 to the 2/3 power. Whenever I start one of these problems, the first thing I do is I circle my index. My denominator is always my index. So I'm going to rewrite this to where my index is 3. My base is my radicand, so that goes underneath. and then squared. So from here, you have two options. You can rewrite, you can put parentheses and put the squared on the outside, or you can put the squared on the inside. So whichever you think is easier. I usually like to put the exponent on the outside because this gives me a smaller number to work with to simplify that radical. So the cube root of 8, well, the cube root of 8, I know what the cube root of 8 is, but if you don't, 8 breaks down to 2 and 4, and then 4 breaks down to 2 and 2. So the cube root of 8 is 2. So now I have, this simplifies to 2 is inside my parentheses. Cube root of 8 is 2. Oops. And I have 2 squared. Easy peasy. What's 2 squared? What's 2 times 2? 4. So 8 to the 2/3 is 4. I don't know who would have known that just by looking at it. However, if you rewrite it with a radical, it's a lot easier to simplify. So let's look at the next one. 16 to the 3/4. 16 to the 3/4. So again, I like to begin by circling my index. So this is a 4th root this time. So we are going to take the 4th root of, keep my base, of 16. And then once I find the 4th root of 16, we're going to cube it. So 4th root of 16, what times what times what times what is 16? So that's a pretty small number to have to multiply something by itself 4 times something, and it's probably a 2. But I'm going to go ahead and break it down anyway. So 16, 4 and 4. Unfortunately, it's a 4th root, because if it was a square root, we would be done. We'd already have a pair, but we got to keep going. So 4, 2 and 2, 2 and 2. Awesome. So the 4th root of 16 is 2. And now we have 2 to the 3rd power. So 2 times 2 is 4, times 2 is 8. That's it. 16 to the 3/4 is 8. But how ugly does that look at first? It's a little daunting. But as soon as you rewrite it with a radical, it simplifies pretty nicely. You are not allowed to use a calculator on these. So when we're giving you these kind of examples, they are going to be something that you can do by hand. All right. Ooh, let's look at this next one. That's a big number. 216 to the 2/3. All right, so what I want you to start with, that's right, that index. So we have an index of 3. So this is a cube root of 216. And once we find the cube root of 216, what are we going to do? We're going to square it. So cube root of 216, let's see, we need to break this down. Now I know what it is because it was one that we listed, but again, if you're like, I'm not going to know that offhand, then you start breaking it down. 216, I'm looking at this going, I don't know off the top of my head, but it is an even number, so I definitely know that 2 goes into it. So if I put a 2 into it, that's going to give me 108. All right, now I've got something a little bit smaller to work with. 108. Will 4 go into that? I think a 4 will go into that. 4 goes into 10 twice with 28 left over, so 27. Hope I did that right. And then 27, I've got a 3 and a 9. Okay, now not everything is completely factored here. Are you with me? Because 2 can't be broken down anymore, 3 can't be broken down. Why? Because the only factors are 1 and itself. But 4 and 9, we can break those down more. So 9 gives me a 3 and a 3. 4 gives me a 2 and a 2. Now remember, this is a cube root. So we are looking for groups of 3. Well, I have 2 groups of 3. I have a group of 2's and a group of 3's. So if I go to take them out, I have a group of 2's and a group of 3's. Okay, so that's going to stay inside our parentheses, and then we've got to square that. Well, what's 2 times 3? 6. And then 6 squared is 36. So even with it being a larger number, it still didn't take forever to factor that. And again, if you knew that the cube root of 216 was 6, boom, you could have stopped right there. You did not have to factor that. Okay, but if you didn't know, well then go ahead and factor it. All right, are we ready for a challenge problem? So the square root of 175k to the third v to the sixth. So this is going to tie in simplifying radicals, and it's going to tie in working with our exponent rules. So it's going to make us think of both. Let's see. 175. So square root of 175k to the third v to the sixth. Let me go double check. K to the third. Yep. Okay. So there's a couple different things that we have to simplify, so I'm going to do one at a time. So I'm going to start with that 175. So let's break that down. 175, I know 25 goes into that, or 5, either one. So pick one and go with it. So if I start with 5, 5 goes into 17, 3 times, 2 left over, so into 25, 5 times. Awesome. Now, 35. Okay, that breaks down to 5 and 7. So I know that I am completely factored because 5, 5, and 7, they're all prime, meaning the only thing that goes into them is 1 in itself. Now, what's our index? 2. So I'm looking for groups of 2. I only have one group of 2. So what that means, a 5 comes out because I did have a pair of 5s. But that 7 is by itself, so it actually has to stay in the radical. Okay? Unless there's another pair coming out of the woodworks, it stays by itself. It's got to stay inside. I can only bring out things that have pairs. So now, k cubed. 2 different ways you can think about this. Remember, we're looking for pairs. Well, what is k cubed? K cubed. K times k times k. So how many groups of 2 do we have? 1. So one group of k's comes out, but we still have a k that's left over. So v to the 6, same thing. You could write out 6 v's, or you could try a shortcut. If I have 6 v's and I'm looking for groups of 2, just divide. What's 6 divided by 2? 3. So I have 3 groups of v's that come out, and were there any left over? Nope, it divided nicely, so no v's were left underneath the radical. And there's your answer. Okay, so once you have pairs, those come out. Anything left over, anything that does not have a partner, stays underneath the radical. Cool? So it's so important that you pay attention to your index. All right, so let's look here. The rational exponent property to rewrite the following. Now pay attention to our directions, because for this problem, it just wants us to rewrite. Like there's not really anything to simplify. So it's just having you look at, let's see, making sure you understand the pieces of the radical so that you can rewrite it. It's also going to have you utilize parentheses, and I want to get into that next. So I'm going to go ahead and write the cube root of x plus 2 minus 3. So rewrite using the rational exponent property. So it wants us to rewrite with exponents. So remember, it's all about the index. Our index is 3. So our rational exponent is going to have a denominator of 3. Now x plus 2. does this have a power anywhere? Does this have an exponent either inside or outside the radical? I don't see one, so the only thing that can be implied is a 1. Now, because x plus 2, because you have two terms under the radical, your radicand is two terms, you must put x plus 2 in parentheses. If not, the only thing that 1/3 will go to is what it's touching. So if you just wrote x plus 2, only 2 would be being raised to the 1/3 power. And then we just have a -3, and it's just kind of hanging on the end. So these are equivalent expressions. They're just rewritten differently. There's no way to simplify that because we don't know what x is. So that's literally all we can do is rewrite. You're done. It's just practicing rewriting. If you are comfortable, you can stop here, but I am going to do a couple extra examples for those who need some extra practice. Again, you can pause at any time if you want to try the extra examples and then come back and check your work. That's fine too. So I'm going to start off with 2 cube roots of 40x squared. Okay, so I got that 2 on the outside. I just need to make sure I don't forget about them till later. Most important part, look at that index. So we're looking for groups of 3. So I'm going to go ahead and break down 40. I know 40, 4 times 10. And then at 4 gives me a 2 and a 2. 10, 2 times 5. And what do you know? We have a group of 3. Fantastic. So we have that initial 2 that was already out front. Don't forget about them. Now we do have a group of 3, so that other group comes out. So now we have 2 2's out front. And now our x squared. Can any of them come out? Well, again, we're looking for groups of 3. So x squared is just 2 x's. So that's not enough x's to come out. So we're just going to head and write our radical symbol. And we had a 5 left over. And the 2 x's left over. So just simplify. 2 times 2 gives us 4 roots of 5x squared. That's it. Can't take out anything else, so you're done. Okay. Next one, square root of 300x to the 4th. So what is your index? Well, there is no index, so it is an implied 2. 300. Ooh, I do not want to start by breaking that down by 2's because that'll take me forever to factor. But I can think of something bigger. 3 and 100. There are many options here, so they'll all work. Why I chose that? Because I know 100 is special. 100 is a perfect square. 10 times 10. Because I'm looking for groups of 2, and I found one. So the 10 comes out. Now, x to the 4th, we're looking for groups of 2. So that's 4 x's, so how many groups of 2 are there? 2. Or again, you just simply divide. What's 4 divided by 2? 2. So 2 groups of x's come out. And then we did have this 3 left over. So don't forget about your leftovers. And all of the x's came out, none were left over. So our simplified is 10x squared root 3. Cool beans? Last one, cube root of 135 a cubed b to the 4th. All right, 135, that's a weird number. Let's see, 135, well I know 5 will go in, so 5 is in twice, 35, so 27. 27 is a 3 and a 9, and 9 is 3 and 3. And again, our index, our lovely index, is telling us that we are looking for groups of 3, and we've got one. So our group of 3 comes out front. And now I'm going to look at my variables. Remember, don't forget about this 5. So that'll stay inside. So now, a cubed. Well, how many groups of 3 are in a cubed? If you want the shortcut, 3 divided by 3 tells us 1. So 1a comes out. So you can just write a, or you can write a to the first, completely up to you. Now b to the fourth, this doesn't divide evenly. So 4 divided by 3 is 1. So there is one group of b's that come out. However, there is one extra. So don't forget to leave the extra one underneath. All right, so I hope that makes sense. You guys let me know if you have any questions or need any help. Have a great day.